I want to welcome you all and thank you all for joining us this evening. I'll be myself and Anirudh will be telling you about how Linux is used in the IoT industries. We'll be basically giving you an introduction to the Linux OS and how it is used in the world of IoT. So to so before we start, I want to inform you all, especially the freshers, that if you find lots of interest in such work and want to participate amongst others who are also like-minded, you should watch out for our recruitments, which we'll be telling you about soon, later towards the end of this presentation. Okay, so
Can you provide us the recording also of this session?
yeah, this session is being recorded, so we'll share it with you soon, maybe
Okay,
by
thank you.
tomorrow. Okay. Okay, so to start off, I want to explain why I have said that Linux is an OS. I just want you to keep in mind that an OS is basically an interface between the computer's hardware and the software programs which will be running on top of them. So as you can see from the graphic aside, I have told that the computer's resources are like the fuel to a car's engine, and the car's engine being the Linux operating system. So basically, this Linux operating system by itself cannot be used. It is not like something you have like Windows or Mac OS. There are other things on top of Linux which allow you to interface with the hardware and make full use of them. So here you can see I mentioned as the type of car being the distribution or the separate kind of packaging of the Linux OS. So you might be aware that Android is also based off of Linux, which basically means all those GUI features, the built-in Google apps, all of those things, they come along with the Linux operating system, and they are packaged as what you call as Android. So there are many other operating systems as well. Here in the image, I mentioned Ubuntu as well as Fedora's Red Hat. It's a Fedora-based operating system. When I say Fedora-based, I will be explaining it to you a little ahead. Moving on, yeah, as I mentioned in the previous slide, and Android is also an OS. Not just that Linux is the OS and Android is some other bunch of software on top of Linux. Uh, Primarily, there are other features like the GUI, the touchscreen GUI, the built-in Google Play, the Google Play Movies, Google Music, or whatever else you have. Those that entire thing allows is can be used through Linux, which is basically at the heart of the entire operating system. Now, how this works is there is something called the kernel, which is the set of most essential programs which allows you to work with the computer's resources. Now, this set of programs is not enough always to work with the OS, work with the computer. So it often comes with some other programs like Android has those GUI features. There is a organization called GNU, which provides such software along with Linux so that it can be readily implemented on top of computer systems. Now, moving on, I want to talk about the different distributions and how why there are so many distributions of Linux, and you hear tons and tons about innumerable amounts of them. So down on the right, I have included a QR code to a page which has a like a family tree of all the current Linux distributions. You can open the link and tap on the image after it loads. It's an SVG image, so you can zoom in and out and have a good look at everything that exists. So basically, how the current structure of a Linux operating system is that the the most fundamental kernel itself is used by a developer to create something like Ubuntu, which is a very uh, user-friendly software. An operating system which you can readily start using on a new computer hardware. Now, on top of that, if you feel as a developer or as a user by oneself, uh, you can add on top of already existing OSs. Like for example, the Raspberry Pi OS has extra features and included libraries which will be necessary for using the Pi to the full potential. And in similarly, there are also other operating systems like, for example, Mint OS, which is a very Windows-like system, if you ask me. And so yeah, if you have any wish to add something to a software to an existing operating system, you can very freely do it, and that is thanks to the open source nature of the Linux operating system. You can join developer communities or just regular user forums to find out more and more about what an OS would require, reporting bugs and whatnot else. So I want to add to all this saying that Linux is something, any Linux operating system which is actively being maintained is always a much better option than something like a proprietary operating system like Windows or Mac, the Mac OS, the OS X, because the any updates required security wise or user nature wise, they are much more quicker and much more frequent compared to those proprietary operating systems. Like for example, recently there was an article which said that an average update being pushed to the Linux kernel takes about 8 weeks, whereas you would have experienced firsthand that you have Windows updates almost every 6 months. And nowadays, they are increasing the frequency of their updates, which is something good, but also something annoying because of the way the Windows update works. But yeah, so to carry on, uh, I want to talk about some different operating systems which are very famous in the world of Linux, and just give you an idea about how Linux is currently used. So as I've said here, there are basically two or three main purposes which an operating system would serve. Now, especially with an open source software, being an open source software, you can make it do different things, and if you are skilled enough, you can make it do the things that you like. So, for example, here I've included Ubuntu. The Ubuntu operating system is very standardized. If you were to migrate from Windows to Ubuntu or even Mac to Ubuntu, it would not be a big problem. Just that you have to deal with the uh, terminal side of things, which we'll be exploring very soon. Ahead, I've also included Kali Linux. Kali Linux is uh, packed with lots of very useful hacking tools or security tools. It is famous amongst hackers and penetration testers, especially in the software industry. Then there are some more ridiculous or even absurd ones like Suicide Linux, or as I've said here, as I included Hannah Montana Linux. They don't really make sense, but they're just fun projects to work on, just to test out your ideas. So if you ever end up having to require to embed some sort of operating system, let's say you are building a smart toaster or a smart mirror, you would often use something like Raspberry Pis or Arduinos for that purpose. And you would require to use some operating system. And most of the times, I'd say you will not require anything besides the standard ones which are already out there. But if you ever have to, you can always make some changes to the operating system itself and how it works and to suit your needs. And now to explain more about what IoT is, our operations lead at ISA-VIT, Anirudh, will be taking over.
Yeah,
Anupam,
sure.
can you check the chat once and answer the question, please?
Yeah, 1 second. So Satrajit is asking, how can you install Ubuntu on a USB drive and use it as a portable OS? So installing on a USB drive, you would do like for a recovery thing. And if you really want a demonstration, I could help you. You can contact me a little later regarding that, and I'll guide you through the steps. So for now, I'll think Anirudh will take over to explain what IoT is.
Yeah,
Anirudh?
sure. Thanks. Okay, hi everyone. So I'll be giving a brief introduction of Internet of Things. So IoT is basically the concept of connecting any device to the internet and other connected devices. It's like a giant network of connected things and people, all of which collect and share data about the way they're used and about the environment around them. So devices and objects with built-in sensors are connected to an IoT platform, which integrates data from different devices and applies analytics to share the most valuable information with applications built to address specific needs. These powerful IT platforms can pinpoint exactly what information is useful and what can be safely ignored. This information can be used to detect patterns, make recommendations, and detect possible problems before they occur, and all kinds of stuff. Could you move to next slide, Anupam?
Yeah.
So now one of the major parts of IoT is a microcontroller. That's the one who's going to enable all connectivity of all devices to the internet. They're designed to perform specific functions and they can be integrated into almost anything, ranging from industrial equipment, warehouse inventory items, wearable devices, home appliances, and much more. One important thing here is to understand the difference between microprocessors and microcontrollers. Processors consist only of a central processing unit, whereas in microcontroller, you'll find a CPU, memory, input, output, all integrated onto one chip. So here the microcontroller acts as the brain of the embedded system. Mostly we use these as integrated on a development board, like we must have seen as common Arduino, Uno boards or Mega boards or even Raspberry Pi boards. Here in this session, we'll be demonstrating some devices controlled via the Raspberry Pi 4B module. So Anupam, you can start off with your Linux demonstration.
Yeah, thank you, Anirudh. So moving on, I'll be showing you how a standard Linux setup works. I'll be using the Ubuntu environment. So these are some things I mentioned here, which we will see the basic commands, file handling. I'll also show you the desktop environment on the Raspberry Pi using my Vnc Viewer. So I would imagine that most of you, if you are here, you might not have a Linux setup ready right now. So you can go to this website. I think Varun or somebody will share that in the chat. You can then, once it loads, you scroll down, then click on Run Online, and it will take about a minute to completely set up the Ubuntu's workstation. So we can answer any other doubts related to what we have spoken so far. You can open your mic maybe, or even put them in the chat.
The the online OS runs with the help of the directly connected to the server, or it runs with the help of our.
Yeah, so I think most probably it runs off of a server on their website. It is basically allowing you to interface via through the internet, just the desktop environment.
Oh, okay. It's
Because
like
yeah, because using an operating system through a web browser, I'm not really aware of, not yet at least.
okay. So it's like more like screen sharing another.
Yeah, exactly. It's the server is sharing the screen of the Ubuntu station to your browser window.
Anupam, there's another question in the chat.
Yeah, 1 second. So Neeraj asks how Linux is better than other OSs. So I would like to say that there is no really better thing about the OS besides the open source nature. It is an OS is completely based on what you require. For example, Windows comes with almost everything you would need to use for daily purposes or general purposes. It also comes with necessary tools that you would require as a super user. But then again, even Linux itself nowadays has developed so much thanks to the increase in computer education in schools and also in colleges, that the Linux Foundation, the Linux community itself has developed so many operating systems, each where you will find the perfect one for yourself as well. So if you think about it in a way that the Linux OS is free and it is openly managed, you can see what all is going on. You don't have to worry about corporation looking on what you do every day. In that way, Linux is a better operating system. But otherwise, if you ask me now, since majority of the users use like iOS or OS X or Windows, it is slightly difficult for someone to migrate from that operating system into something like Linux. So it is completely subjective to answer in one line. Vishal is asking how to dual boot a system. In brief, I'll say you have to make a disk partition. Uh, the disk partition will have a different file format because Linux uses a different file system compared to Windows. So you will have to do that disk partition, flash the operating system into that disk partition, and when you first start the computer, you have to get into the BIOS and then manually walk into that disk partition where the OS is living. So it is not entirely useful that way, but yeah, you can do it. A better option would be to use something like a virtual machine. Maybe I'll demonstrate that too. I'll just show you my virtual machine that I have. Okay, it's been 5 minutes. I hope everybody has their Ubuntu thing ready on their browser. One thing I will warn you is that if you don't interact with it at least once every 5 minutes, it might just shut off and you have to do the whole thing all over again. So to start off, I want to tell you how to open the terminal, because we'll be working on the terminal for a little bit. So I'll just comment that yeah, so I've commented the shortcut which you would require to open the terminal. That's Control Alt T. We'll just wait for a few seconds if anyone has any problems. Okay, so meanwhile, I'll show you how I log in into the Raspberry Pi, which is already right now. So I hope my terminal is visible. Can somebody confirm?
Yeah, it's visible.
All right. So since the Raspberry Pi is in no way connected to my laptop right now, not even through a USB interface or Ethernet, I'll have to use what is called a secure shell, which works over the Wi-Fi. And via secure shell, I can log into the Raspberry Pi's operating system, which is already running. Okay, first I have to turn on my camera. So I hope you can see my setup here. My camera was off. I'll just turn it on 1 second. Okay, so I think it's visible now, right? Anirudh or somebody.
Yeah, it's visible.
Yes, visible.
Okay. So as I said, I was going to log into the Raspberry Pi using something called a secure shell. So now this is my terminal on my Windows system. I'm running the command prompt here. So to SSH or secure shell into it, I write SSH followed by the username on the operating system, and then followed by the IP address on the local network. You see it has it was able to talk to the Raspberry Pi, which is online right now. I think you can see by the red light here somewhere. Maybe if you notice that it's on. So now I type in my password, and we are in the Raspberry Pi now. We can talk to it. So now I'll show you some very fundamental commands which a user would require. So first of all, you might not know what your username is, and to do that you can say who am I, and you can see here that it says I'm the Pi user. You can also tell by Pi at Raspberry Pi. At Raspberry Pi would mean that that is the local host name, or you could also say the device name, which would when you look at the network. Okay, another thing you would want to do is see where, like, you can't say where you are in the in terms of file, where in the file system are you currently standing. So, which is in technical terms called the directory. So to do that, to find out where you are, you do something called print working directory. And to be honest, the Linux file system itself is very complicated and would require a session by itself. And if anybody has questions regarding that, you can message me on Teams or here on the chat. You can put your doubts in the chat about the directory system. And since it's so complicated, I won't really be telling you a lot about it. I'll just tell you that you as a user have your own working directory, which you can see here is Pi. So how do you move about from one directory to another directory? So for that, you would want to use something called change directory, and the command is called cd. And if you don't know what directory to go into, you would first want to know where which directory you would like to go to, and here you don't know which directories already exist, right? So to find out what directories exist, you would type ls, and ls basically would mean that you are listing the current directories, subdirectories, or whatever folders are currently there in the folder you are already in right now. Okay, so I think you are able to follow along on the Ubuntu station you had opened earlier. So if you have any doubts so far yet, or any problems, you can put them in the chat. I'll wait a few seconds.
Anupam, you can check out the chat, please.
Yeah, 1 second. Can you use online? The question is not really clear, Linkesh. If you mean to say that you want to log into
I'm sorry. Like, can I do this command prompt run in this Ubuntu online, or
No, that you can't do because you don't have the network address and the password details, right? So
yes.
so that becomes a little complicated. If you actually had them, I would show you how to do it. Like I showed you here, you need the username and the IP address, right?
Yeah.
So if you find out those details along with the password, you can try that out. I would really
Can I
encourage
use
that.
yours? Can I use yours?
No, because I have not opened it to the internet. I would have to do a separate setup for that. I have to configure my router and everything. That's a whole other deal.
Oh, okay.
You want to know about that? I can give you some details too.
Yeah, sure.
Okay.
If you're completed after completing what you're doing,
Yeah,
and
that's
then
what I meant.
yeah.
Yeah, I'll give you those details later.
Sure.
Okay, so here, what we did here is find out where we are in the directory and find out also what other directories we can go to. Now the question is, how do you go to them? And for that, you would basically be doing something called changing your directory. And the acronym will be cd for that, and that is basically the command by itself. Let's say I want to go into my documents folder. So I would write cd documents. You see here, it has, I am inside the documents directory right now. Now, if I type ls, I won't get the same thing what I got here because I'm in a different place altogether. Now, if I wanted to go back, I would try writing like home, or it would tell me that there is no such thing as home. But I could do this here. I mean, what I've written with the print working directory, right? Which is /home/pi. If I did that, I would go back to the same place. I mean, what is known as the home directory for the particular user. So now I'll be going back into documents, and I'll show you another way to navigate. So if you want to go one directory up, which is, if you're in documents, if you want to go back to home, you can just write cd ... and you're back there. So say I want to do, I went back to documents, and I went inside documents, there's a folder called Pi work, which is for Python work. Say I wanted to go back to the home directory, I would write ... which is basically going back upwards twice. And you see here, I'm back in the home directory. Now, there's another interesting feature about operating systems is that they have something called hidden files or hidden folders. So those are critical to the system's operation, but those are not really anything useful for the user themselves. So to view those hidden files, you would give this option called -A. So as you see here, compared to ls, just simple ls, there is so much more information than the standard command. So there are so many hidden files. These are called dot files or dot folders. They these also exist on your on your Windows or your Mac systems as well. Another thing I would like to point out here is the double dot directory here, which means that this command, the cd dot dot, which you did, was basically going into a directory which already exists, and this is something linked by the Linux file system. And now you see here, I've done cd dot dot, and I'm outside my user directory now. So in order to go back to my user directory, the home directory, I would just write cd and I'd be back there. If I did pwd, it's the same as the previous one. And now I would like to show you some so in the next in the agenda, I wanted to show you how to write programs and read things, what is written in a file. So if I go to my documents directory, then before that, if you want to try going about directories, you would want to have to make some directories, right? So in order to make a directory, you write make dir followed by the directory name. So let's say I want to call it test directory. If I go into test directory, I go write cd test directory. You can try this on your system, on your Ubuntu machine or whatever you're doing right now. Okay, so I wanted to show you how to write programs or read what is written in a file. So to do that, I'll go to the documents which I have prepared for this session. So here is PyWork, which is Python work. Now I want to see what files are existing here. So there are buzz test and RGB module 1.python. These are files I'll be using to run, show you the IoT related demos. So if I want to see what is written inside a file, I use a command called cat. So I use there are other commands as well. If I did that, you would see the Python program I have written to demonstrate the buzzer application here. So you can see the import statements, the while statement, and everything. Now, if you wanted to edit this program, for example, you would have to use a editor, and you would imagine how do you get an editor into a terminal system without GUIs? So the Linux system has editors like Nano and Vim and many others, Emacs and V. So I'll be using Nano for this app, for this moment, and Nano followed by the file name. If you did not have a file already existing, you could also simply type nano space the file name, the new file, like test.py. Okay, so you write test.py, and I want to write print hello world, right? And to save the file, you would do Control X followed by, you see here, it asks you to say yes, you hit Y, and then the file name to write to is test.py. And if you want to change the file name, you can change it here. Otherwise, you can just hit enter and it has saved the file. And when you do ls or list the file, you can see here test.py is already there. Now, if you want to run the program, you would have to use the Python interpreter there. So I write Python 3 for Python 3.8, and followed by the file name. So you see here it has printed, it has run the program and it has printed out hello world. So the program itself you want to see is here, print hello world. So any questions so far? I'll be reading from the chat. Yes. Okay, so Aman asks how to make a bash file and convert it into an executable. So this is a great question right now. I'll just go ahead with that. So I want to cd back into documents because I already have a directory where I keep all my bash and shell scripts. Okay. So there is here you see shscr for shell scripts. So I do sshcr. And now if I want to make a shell script, I do nano new script will be the file name, followed by .sh to indicate that it's a shell script. Now, if you want to run it without having to deal with any other complexity like an interpreter or other things, you can mention how the file will run by using something called shebang or hashbang, which is this followed by the directory where the interpreter or compiler or whatever already exists. So that would be user bin for binaries and followed by environment, or it would be an environment besides that. And you would say bash or even shell. I'm just going to say bash. Many times what I have tried, it usually becomes a little complicated. So I'll show you another way how to run them. So anyways, so the shell script language itself is something different comparatively. So in order to replicate what I did with the Python program, I'll just show you how to do that. So the echo command, the echo keyword is equivalent to the print command in Python. So if I want to write echo hello world, just write that, very simple. And how I save the file is I do Control X followed by typing yes for Y for yes, and then I hit enter. And now the file is ready to be executed. But if I want to execute it, I type new script.sh. It would say that the command is not found, but if you want to run a program, you would usually do something like new script.sh. It says permission denied. Now, how you run this is by changing the permissions. And to change the permissions, you do chmod, which is modify the how the file works. I mean, the write permissions, the append permissions, the executable permissions, all of those. Now I want to change it to be able to execute. So to indicate that, I write +x, which means I'm adding the executable feature to the permission to this file. And the file name I type new script.sh. That is change permissions, add execute, and the file name. Once I do that, I can do the same thing, new script.sh. Here you see I have made a mistake. I don't know particularly the file where the bash interpreter is located. So what I do in that case is I run it by source, which is another command which you can use to run a shell script or bash script, followed by the script's name. So here you see it finally works out, showing you the hello world output. Now to see what I wrote there, you write cat for concatenate and new script, and that's the program and that is output. It's very simple. Any doubts so far? I would like to Okay, Aman is asking what is source? What is the source command? Source is basically telling the operating system that I want to use the shell itself, the bash shell, to run to run that script. Like if you tried source, I went to the Python program, which is one directory up, and do source. Let me find out what files are there. So source test.py. It says syntax error, expected unexpected token, because you see here it says bash unexpected tokens and all, which means that the bash script itself was it's the only thing that can run on source. I hope that clears your doubt, Aman. Okay, great. So if anyone wants me to write a program in C++ or Java or JavaScript, you can tell me. I could show you how to do that too. Okay, I'll just a program in C. Okay, let me try. I think I've forgotten. So I'll go back one directory and go to my C folder. Then I make a file called new program.c for the C thing. And now I write, now I start the program. I say include the stdio.h header followed by IO stream, the input output stream. I can say printf hello world. I save the file, Control X, yes, enter. Now to run the file, I have to use a compiler. And the compiler which exists here is the GNU C compiler, which is I can access by GCC. GCC followed by the output, which is going to be just okay. So it's called new program.c. So I write GCC output to new program.exe, the executable, and then followed by the file name which I want to compile. Here you see that there is an error, which means the compiler is working great. So I made a mistake saying it was not supposed to be iostream.h. Now I'm supposed to edit it. So I write nano new program.c. I don't want to remove this line. I'll just comment it out. Then I save it, Control X, yes, enter. Then I use the arrow keys to go to previous commands and I try the same thing out. And you see here it has found another error. So I have to correct that as well. Sorry if I'm really bad with this, because the last time I did C was probably in first semester. So
you have to use void main.
yeah, I just forgot to use a main function. So here I've included the main function, and now I make sure it works properly, because I don't want to waste your time any further. So I've saved the file, I compile the file. There you see there are no errors. And now if I want to run the file, I run the .exe version of that file, which is new program.exe. And there you go, the hello world has come out, but there are some, should have included like a new line character or something. So I compile that again, and if I run that file, you see it works great. Okay, so I'll just quickly go back to the slides and show you what else was in line. So I wanted to show you, as you can see in my video, if you pin my screen in the meeting to, not my screen, sorry, my video, you will be able to see some demonstrations that I'll be doing right now. So here you can see there is an RGB module, okay, which is a bulb basically connected to some resistors and then to the output pins on the Raspberry Pi. If you've never seen a Raspberry Pi, I'll show it to you here. So you can see these pins here, which can be connected to various electronic devices to control them by programs uh, uh, or just power them. There is also a 5 volt pin which I'm using to power my fan, as you can see here. And okay, going back to the demonstration, I have some programs ready to show you. So first, as I was saying, the RGB module here, which is the bulb here, if you just keep your eye on it, and so I have a program called RGB module 1.py. Sorry, I should have said cat. So there you see, that's the whole program I have written to control this electronic device. So if I want to run it, I write Python 3 RGB mod 1.py. And if you take a look here, you can see it's changing colors. The colors I have listed out here in this list object called colors. These are all hex values, or I think you can also try some. There are standard colors in this module, but I would recommend you try out some random colors. And then, okay, sorry, I don't think you can do this yourself anymore. I just recommend you watch my video, my camera feed. So that's the RGB module that I wanted to show. Now you see here how this runs is that there is a infinite loop running here in this function called loop. So if I wanted to exit out of this program, I'd have to do something called keyboard interrupt. And that does not mean you can press any random keys. So for example, if I press random keys like this, it does nothing. And if I press enter, it still does nothing. So there's a special combination called a special combination to initiate that interruption, which is control plus C. So you see that here it has stopped the program, and here I've called a destroy function to stop the LED. So if you have any questions regarding that, I can take them now before we move on to the next one. Okay. The next I had in plan was the buzzer. So as you see, I have a file called buzztest.python. I run that file by saying python 3 buzztest.py. So I think you can hear the buzzer buzzing there. Just a second, let me show you the contents of that file as well. Yeah, so you can see here too, there is an infinite loop running. So if I wanted to exit out of it, I would do control plus C. And that's how you stop the an infinite loop.
You have connected a buzzer also, like.
Yeah, sorry, I did not show it to you. So if you see this black spot on my breadboard here, this is the buzzer which I have. Let me try to zoom into it. So you see this part here, which is attached to some pins on through these wires. This is the buzzer which I'm running with this program here. I'm able to access the thing using this. There's a feature in the Python library called buzzer in the electronics. This is built into the Raspberry Pi system, operating system.
Oh, okay. Okay, got it.
Okay. So the last thing I wanted to show you was the camera module. This camera module, I'll try to show you. So it is basically loosely hanging around because I've not really bothered making something special for it. So this camera module is about like 5 megapixels, and it's a decent if you want to use it for like a CCTV or something as well. So I'll just leave it there, and I have made a shell script to show you how it works. So I go back one directory and see my shell scripts directory is sh and here I have a shell script ready called testcam.sh. So the command is very simple. libcamera still is it's an open source, openly developed camera application for devices like the Raspberry Pi or even the Arduino. So then I've added an option called vflip, and which is telling the camera to flip the image vertically, because you see here the camera is supposed to actually be like this, but I can't really do that. So I just left it hanging like that. So I flip it, and the output option -o, it goes to test.png. All right. So you would imagine how I would want to look at the image which has been taken by this camera. So I need an application to look into the desktop environment of the Raspberry Pi. So to do that, I use something called the Vnc Viewer, which is free for personal usage, and you can use it to even try to log into view your Android device on this through your laptop. You can even try to interface with it that way. Okay, so here you see it is so much more convenient. It is almost like Windows, you could say. Just that there are some navigation changes here. So here you see I'm in my shell script directory. Sorry, I go to documents and then shell scripts. And here's an image I had taken earlier. You might don't mind the wire which is connected to my camera. So here you see it is a very decent quality. It's not really something you would use every day. You could also use it for nowadays. You could use it for like computer visualization using Python and ML features. So recently I tried making a time lapse, which went very horrible. But here you see I was able to automate taking pictures using a Python file. If you want to know more about this, you can message me later. So you can see there's all these images automatically taken. You can put them in a video editor and create the time lapse.
Anupam, you can check the chat for further questions, please.
Yeah, 1 second, sorry. Raspberry Pi module capable of continuously. Yeah, of course, as long as you can power the Raspberry Pi itself, right? You can use the camera. But different cameras have different limitations. So there are different camera modules, if you don't mind me showing. I'll just close the desktop environment. If you have any questions regarding that, I can take them later. So, okay, so you go to hardware, and from the Raspberry Pi. So you see here, there's a much better quality camera which does better things. This is the one which I have, the oldest one. This one is capable of detecting even infrared, which you could use for different purposes. So yeah, to answer your question, yes, I can run it for how much ever time I want, as long as I can power the thing. Okay, so that's about it from our side. I'll just, to log out, I'll show you. You can just type log out. Very simple. It has closed the connection.